So if I draw an angle of 1 radian, what is this arc length right here? Think back to when we had the pipe cleaner and we went around and the pipe cleaner was the same as the radius. We wrapped around the unit circle. So what is 1 radian, this arc length? 1 radius. So what's this arc length? As the radius gets bigger, it's still 1 radius, right? So the circle gets bigger, the circumference is proportional to the radius. So then what's the arc length of the bigger circle? Yeah, it's still 1 radius. So even if you get larger, the radius gets larger. So it's still going to be 1 since the unit gets larger. So if this is my initial side and this is my terminal side, in what quadrant, if I drew an angle of 5 radians, would the terminal side be? Any guesses?
Quadrant 3.
Quadrant 3? Okay. Well, instead of just guessing, we can use the wrapping function to actually find out. So the wrapping function takes a number line and it wraps around the unit circle. So that if we go counterclockwise, every positive number has 1 location on the unit circle that it relates to on the number line. And then if we go clockwise, every negative number has a relation to 1 specific location on the unit circle as well. So to put this into practice, this is a picture taken directly from your textbook because you are going to do this for your So here's 5. So if I draw this angle, so this is my angle of 5 radians, what is this point? Can someone give me some coordinates? And just estimate.
You could also open your book to the deal and look at it there. If you can't read it from the screen, it's your homework problem. So you could open to the homework in the section and see the exact same graph.
3.4. So it's on page 166.
Draw the lines to this sheet to see where the X and Y is. I don't think they understand it.
Okay. So here's my X and then there's my Y. So what X and what Y coordinate make up this point 5?
It would be like 3 negative 9.5.
Yeah. 3/10 and negative 9/500. That's right. So what is this length right here?
3.
3 what?
Oh.
3/10. Right.
Okay.
And then what's this opposite side of this theta roughly?
95 hundredths?
Positive or negative?
Oh, negative.
Yeah, negative 95 hundredths. So, what would the point be if I asked for 8/10 radians? Eight-tenths is right there. So look at your circles. Look at your textbooks if you can't see on the screen well.
It's like 0.7 and 0.7.
Yeah, 7/10 and 7/10. Both positive because we're in quadrant 1. So if we look, so we could draw the triangle up here and down here. And so this length right here is 7/10. And then what's this height? Yeah, 7/10. So we're going to look back at this first triangle that we built. And what's the radius of this circle? Look at your x-axis. How far does the x go for your radius, since it's labeled? 1, right. So the hypotenuse on this triangle that we first drew is also 1. So if I wanted to find the cosine of 5, what would the cosine of this angle of 5 radians be? If this is the theta we're looking at.
0.3 over 1.
What over 1, right?
0.3 over 1.
Yeah, 0.3 over 1. 3/10 over 1. So if that's just an estimate, because this is not exact, since we're using just a grid. So if I go to the calculator, and I want to find cosine of 5, I want to make sure that I'm in radians and 9 degrees, which I am. And I'm going to enter to evaluate this, and I'm going to get 0.28366, and it goes on for a bit. That is really close to our estimate of 3.3 of 3/10. So see how we use the unit circle to find an approximation for our cosine. So what do you think sine of 5 is? What's sine of 5?
Negative 0.95.
Yeah, negative 95 over 1. So what do you think we're going to get if we plug that into the calculator? What do you expect to see on the calculator?
Something close to,
What, Anthony?
something close to negative 9.
Yeah, something close to it. And look at that. It's really close to it. So we're using a wrapping function to help estimate the approximation for our cosine and sine values. So if we see this point of 3/10 to negative 95/100, what's another relationship that we can see? What can we call this 3/10 instead of 3/10? What did we just find? What is equal to 3/10?
Cosine of 5.
Yeah, cosine of 5. So I can say cosine of 5, and then what's my y-coordinate now?
Sine of 5.
Sine of 5. And that relates back to Tuesday's lesson with Courtney, and she said that cosine is related to the x-axis and sine is related to the y-axis. So you see how that coordinate is now made up of trig functions for the unit circle? All right, so if we know, okay, we're going to look at the wrapping function. So t is your distance that you're going. We went 5 radians, and we ended up down here. But our output was a point. So that's how the wrapping function works. If you find a distance, you're going to output a point. If you're given a point, you need to be able to find the distance of where that point ends up. And that's how the wrapping function works. So we're going to now look back at our definitions of our trig functions. So what, using x, y as the radius, like Courtney said, what is cosine of t equal to?
X value.
The x. And why is it just x? Why isn't it x over r? What's the radius of the unit circle? 1. So if it's x over 1, it's the same thing as x. So what about sine of t?
Y.
Y. Same thing, y over 1, because the radius is 1. So what's tangent of t in terms of x and y? Really close. Y over x, right. We're going to put our sine over our cosine, right. And then secant, what's it the reciprocal of? Cosine, right. So if we want to switch the numerator and denominator of cosine of t, what would that end up being? 1 over x. And remember the radius is 1, that's why 1 is in the numerator now. What's cosecant the reciprocal of? Sine. So what does cosecant of t turn into?
1 over y.
1 over y. Gotta speak a little louder. What's cotangent of t the reciprocal of? So cotangent of t is now what? X over y. Right. But if we look up at this top, we know that cosine of t equals x. So we know that x equals cosine of t. So if we go through tangent of t, secant of t, cosecant of t, cotangent of t, we can replace by substitution every x with a cosine of t and every y with a sine of t. So what does tangent of t then become?
Sine of t divided by cosine of t.
Sine of t over cosine of t. What about secant of t? replacing all the x's with cosines of t's and all the y's with sine of t's, what does secant of t become? 1 over cosine of t. What about cosecant of t?
1 over sine of t.
1 over sine of t. And then what about cotangent of t?
Cosine of t
Cosine of t over sine of t. So all of these ratios, the secant of t and cosecant of t, are called our reciprocal identities. And then tangent of t and cotangent of t are our ratio identities. And you have to remember all of these for your non-calculated portion of your test. You're going to have to know the values at different angles. You have to know how to use your coterminal and your reference angles, and then know how to simplify and break these down to get them into one expression. We'll go into that later in our lesson as well. Alright. So, I want you to discuss in your groups. You don't have to find a solution. I just want you to discuss how would you solve this equation. How would you find the exact value of cosecant of 5 pi over 6?
Yeah, sure. Find the sine value over 6. Just by taking 1 over whatever you did. That's your answer. You say 1 is the fine value of
You guys use a calculator? You guys are full radicals eventually? 2 radical over 2. I think I have some, but I gotta know.
Okay, so because when equals means you can go back and forth. So
I don't have to. You start
and
thinking
x
about it.
equals cosine of t. So I can replace this x with cosine of t because they're equal. And the same thing with sine. And that's how I got to that identity. Okay, so I'll go back. Alrighty, let's go back one line and look at what cosecant is related to. What is cosecant of t related to? Sine of t, right, because they're what? Reciprocals. So they just switch the numerator and denominator of each other. So if cosine of t equals x, then x equals what? Go the other direction, x equals what?
Cosine of t.
Cosine of t, right. And that's how we got the substitution over here. Wherever there was an x, I can directly replace it with substitution for cosine of t, because they are equivalent. And I can do the same thing for y. If sine of t equals y, what does y equal?
Sine of t.
Sine of t. So wherever I see a y, whether on tangent of t, cosecant of t, and cotangent of t, I can replace it with substitution using sine of t. And that's how we got these identities. And you will have to know these for your non-calculated portion of your test. And so you don't need to look up here. You can just switch them out and use substitution on your own. Okay? So, going forward with that, how would we solve cosecant of 5 pi over 6? We're going to first look at what other trig function, what relationship does cosecant have with another trig function? Right, sine. So, cosecant is related to sine how? Yes, the reciprocal. So I can say this is equal in the unit circle to 1 over sine of 5 pi over 6. This is the reciprocal. Okay, we're getting kind of closer. Do we know sine of 5 pi over 6? Right off the bat.
What?
It's not one of our special right triangles. So we're going to have to use the unit circle. And where is 5 pi over 6? Which quadrant? 2, right. So 5 pi over 6 is right here, and that's my angle. So if I want to find the sine of 5 pi over 6, what do I have to use?
Reference.
Reference angle. Did you watch the video, Wyatt?
No, I just done this.
Oh, okay. No one else has watched the video yet. So, yes, this is called your reference angle. How did you find the angle of this reference angle? If this is 5 pi over 6, and we know this right here is pi, how can we find this measure?
Subtract them.
Subtract what from what?
Pi from 5 pi over 6.
Yeah. Pi from 5 pi over 6?
5 over 6 minus 1. Pi.
Minus 1?
Minus 1 pi.
So if we have 5 pi over 6, and we subtract pi, we have to get a common denominator, so we'll have a convenient name for 1. So 5 pi over 6 minus 6 pi over 6. Does this give us a positive or a negative angle?
Negative.
Negative. So this is not what we want. We want to switch the order up because we're going counterclockwise. So this reference angle is going to be a positive angle. So which order would the subtraction go in, Anthony?
Pi minus 5 pi
Right,
over 6.
pi minus 5 pi over 6. So again, I'll have a convenient name for 1, 6 over 6. So that gives me 6 pi over 6 minus 5 pi over 6. And what's that? It's positive. What does that angle measure? 5 over 6, right? So do we know sine of pi over 6? What's sine of pi over 6? Right, 1/2. And that's using your 30, 60, 90 special right triangle. And if you don't remember that, pull out your equilateral triangle, or draw it over on the board over there with your perpendicular, and find your side lengths using Pythagorean theorem, and you can find sine of pi over 6, or 30 degrees. So sine of pi over 6 is 1/2. So we know that the value is 1/2, but let's look at the sign, S-I-G-N. What is sine in quadrant 2? Positive or negative? Negative? Why?
Positive.
Positive. Why?
Because the y value is positive.
Right, because sine is related to our y values, and the unit circle, this is the positive y-axis. So sine is also positive. So we're going to leave it as a positive 1/2. So what is 1 divided by 1/2? 2, right. Because we're going to multiply by the reciprocal. So it's just 2. So cosecant of 5 pi over 6 is just 2. What questions do you have? No questions? Alright, so as the wrapping function had a domain, you inputted a t, which was how far you went around the unit circle, and the range, or the outputs, were your points. We can find a domain and range for our trig functions as well. So what numbers can we put into cosine of t? Or is a better thinking question, are there any numbers we cannot put into cosine of t? Okay, so let's go to our unit circle. So cosine is related to what? X. So if we look, we're putting in, the X is our output, the T is our input. So if we're wrapping a number line around, are there any T's we cannot put in? We can go negative, yeah, because if we go clockwise, we can give the negative values as well. So are there any positive or negative values that we cannot put into the cosine function? Right, no. So cosine's domain would be negative infinity to positive infinity, because we can put in any and all numbers for our domain. What about our outputs? If we go back to our x's, because that's our outputs, is our x's on the unit circle. What's the minimum value and what's the maximum value for our x-axis? What's our minimum? -1, because this is your radius. And a radius is what in the unit circle? What's the radius for the unit circle?
1.
1, because it's 1 unit. It's 1 radian. So, our minimum value is -1 right here. What's our max value?
1. 1.
Positive 1, right. So our range is going to include the negative 1 and include the positive 1. And this is written in integral notation. So the parentheses mean there's no value because you can't reach infinity, and the bracket means there is value. It includes the negative 1 and includes the positive 1. So what about sine of t? What numbers can we input for sine of t? We go back to our circle. We can put in any and all positives, and we can go the other direction and do all the negatives. So are there any that we can't put in? No. Okay. So sine of t's domain is the same as cosine, negative infinity, positive infinity. What do you think the range is for sine of t? Yeah, the same. So if we go back to the unit circle, look at our y-axis, because that's what sine of t is related to in a unit circle. What's our minimum value? Negative 1, right. What's our max value?
1.
Positive 1, right. Whoop. So our range is the same, negative 1 to 1, included on both sides. And so this is the whole range, between negative 1 to positive 1. What about tangent? What do you think that domain is?
Infinity to infinity.
Negative infinity, whoop. Negative infinity to infinity. But let's look at the ratio identity for tangent. What did we get on the previous slide? What's tangent to t? Equal to. Right, but in terms of sine to cosine to the unit circle, right, sine of t over cosine of t. And what's the number we can never divide by?
0.
0. So when is cosine of t equal to 0? If we go to the unit circle, when is the x-axis 0? Give me some just random examples of radian measures.
Pi over 2.
Pi over 2, what's another one?
3 pi over 2.
And if we kept wrapping, what's another one? What's the distance between pi over 2 and 3 pi over 2?
Pi.
Pi. So if I went up, added pi to 3 pi over 2, what will I land at? I'm doing it into 1, 3 pi over 2, plus 2 pi over 2 gives me what angle?
5 pi over 2.
5 pi over 2, right. So, we're going to ignore, we're not going to figure out the ranges for the rest of these trig functions. You'll see those later when we graph them in 2.5 and 2.6. So, I'm going to continue writing over here. So, if I have pi over 2, I have 3 pi over 2, and 5 pi over 2. You see a pattern? Okay.
It's all over 2.
It's all over 2, right. And what else do they have in common on the numerator?
They add 2.
Right, they add 2, and we're going to start with an odd number. So every odd number times pi over 2 will get us 0 for cosine of t. So, it worked. Okay. So, if I have t cannot equal 2n plus 1 times pi over 2. The pi over 2, as Taylor pointed out, is what everything had common. The 2n plus 1 is just a way that mathematicians write odd numbers. So if I plug in a 1 for n, 2 times 1 is
2.
plus 1 is
3.
right. So for any integer I plug in, I'm going to get an odd number, whether it's a negative odd number or a positive odd number. And t cannot equal that, since that's when cosine equals 0. So what's secant of t's in terms of sines and cosines? What's secant of t as reciprocal?
1 over cosine of t.
1 over cosine of t. So what's a number we can never divide by?
0.
So when is cosine of t equals 0?
Same values as tangent.
Yep, the same value as tangent. So we can plug in all reals, but t cannot equal any odd number times pi over 2. What questions do you have so far? All right. So we're moving on to cosecant of t. What's its reciprocal identity? 1 over sine of t. Correct. So, what number can we not divide by? 0. So when is sine of t equal to 0? On the unit circle, sine is related to y-axis. So where is y 0? Give me some angle measures in radians.
0, pi, 2 pi.
Hannah got it. Okay. Oh my gosh, again. Okay. So, I have, well, 0, and then I have pi, and 2 pi, and 3 pi. What's this pattern? Yeah, you're adding 1. So, I'm going to have all reals, but t can't equal any n times pi. N is any integer. So it can't equal 0 pi, 1 pi, 2 pi, 3 pi. Can't equal negative pi or negative 2 pi. Alright, what about cotangent of t? What's its ratio identity? Cosine of t over sine of t. Why? What other trig function is cotangent of t related to? Tangent. What are they? They're reciprocals, right. So if tangent of t is sine over t over cosine of t, cotangent of t is just switching the numerator and denominator to get cosine of t over sine of t for the unit circle. So what numbers can we not divide by? 0. So when is sine equal 0? Yeah. So t can equal n pi or cannot equal n pi? It cannot equal n pi because since you cannot divide by 0. And then what else is our domain? Negative infinity to infinity. Right. So these will all help you on the graphs to make sure you get them correct. But then also, if you find a cosine value, cosine of t, that's negative 2 or less than negative 1 or greater than 1, you know you got it wrong because that's not in the range for cosine of t. So these will help you check yourself after you've done your work. Alright, so this is a t down here. You can see it in your books a little clearly. But t is the distance we're going. So let's just say I'm going to go pi over 3. But then I'm also going to go a negative pi over 3. Why is it a negative pi over 3? If I go this direction. Right, so clockwise always is a negative angle, and then if I go counterclockwise, then it's positive. It goes in the directions of the quadrants. So, what would cosine of pi over 3 be? What is pi over 3 in radians, in degrees?
60.
60 degrees, right. So, if I have my triangle, it's equilateral, so what's this beta right here? 60 degrees. That changed to green. What's this angle right here? 30 degrees. So, and this one right here? 90 degrees, right. So, if I make every side length of this 2, and if this bisected it, what's this side length right here? 1. So, let's use Pythagorean theorem and find this perpendicular. So my hypotenuse is 2. So I'm going to square the hypotenuse, and that'll equal what? And then we'll just call it b squared for now. So what's 2 squared?
4.
What's 1 squared? And then plus b squared. And now what do I do? I subtract the 1. So 4 minus 1 is 3. And that equals b squared. So now what do I do? If I square both sides, b equals what? Plus or minus radical 3. But then which of the values do I take? The plus radical 3 or the minus radical 3? For this side length. Which one do I want?
Plus.
Plus, because distance is always positive. Right. So this is about 3. So if I want pi over 3, if I want the cosine of that, what side length of this triangle am I going to look at? What's the ratio for side lengths for cosine? Using opposites, adjacency, and hypotenuse. What's the ratio for cosine? Adjacent over hypotenuse. And pi over 3 is which angle? The 30, 60, or 90? The 60. So if I'm using this as my theta, the adjacent side length is what? The adjacent leg
1.
is what?
1.
1. Is 1, and then the hypotenuse is 2. So cosine of pi over 3 is equal to 1/2. Right. So I'm going to go back. And back. It's 1/2. So what's the cosine if I go negative pi over 3?
Negative 1/2.
Why negative? Can you speak louder?
Because it comes clockwise.
Because we're going clockwise, so the angle is negative, but what axis is cosine related to? The x. So is cosine positive or negative in quadrant 4?
Positive.
Positive, right, because the x-axis is positive for quadrants 1 and 4. So if I drew, I'm drawing a negative pi over 3. So that'll end up in quadrant 4. So cosine's positive in quadrant 4. So cosine of negative pi over 3 is what?
1/2.
A positive 1/2, right. Positive 1/2. So, just in general terms, if I plug in the opposite of t as my input, what's my output going to be in terms of cosine of t? If I plug in the opposite, so negative pi over 3, did I get the exact same output as I did for cosine of pi over 3? Right. So I can say cosine of the opposite of t is equal to cosine of t. If I know that I can input the opposite of our original input, and get the same output, what do we know about cosine as a function? This reverted back a couple weeks ago. If I can input the opposite of the original input, someone said it, it's even. Right, so cosine is an even function. So what about sine? Do you think that's odd, even, or neither? Just guess. Pick one. You have to talk a little louder. Odd? Okay, good. So we'll just put your guess down here, and we'll say odd. All right, so what is sine of pi over 3? Square root of 3 over 2. You can get that using your triangles if you drew them on your sheet as well. So what is sine of negative pi over 3? Why is it negative, Wyatt?
Because it's in the bottom half of the circle.
Yeah, it's in the bottom half. And what else is negative in the bottom half? That helps, that makes sine negative.
The y values.
Yeah, the y values are negative for quadrants 3 and 4, and that's how we got sine to be negative as well. So, if I input the opposite of t, what is my output for sine?
Opposite.
The opposite of what? Sine of t. Right. And does that prove Hannah's guess that sine of t was odd? So if we input the opposite of t and get the same original output, then it'll be an even function. But then if we input the opposite of t and get the opposite of the original input, that original output, then we get an odd function. Let's try tangent. What's tangent of pi over 3? Or, a better question, what's the ratio identity for tangent?
Sine over cosine.
Yep, sine over cosine. But what's our input in this case? Pi over 3, right, and that's our t value. So pi over 3. So what was our sine of pi over 3 for our first one? What was sine of pi over 3? Yep, square root 3 over 2. What was our cosine?
1/2.
1/2. So if I simplify this fraction, what do I get?
Square root 3.
Yep, just radical 3, square root 3. Because the 2's in the denominators will divide out, so we simplify to 1. So what is tangent of the of negative pi over 3? Let's use the same ratio identity. So we have sine of what? Sine of
Negative pi over 3.
negative pi over 3. And cosine of negative pi over 3. What was sine of negative pi over 3?
Negative 3. Square root 3 over 2.
Negative square root 3 over 2. And what was cosine of negative pi over
1/2.
3? 1/2. Right. So if we simplify this fraction, what do we get as our output? Yeah, negative square root 3, because once again these denominators will divide out. So if we have the opposite of t as our input, what is our output in terms of the original?
Opposite tangent of t.
Opposite tangent of t, right. So what does that mean about this equation? What does that mean about this function? The tangent, even odd or neither? Odd. What other function do we know that was odd that we just came up with? Sine. Right. So, put it all together, cosine of the opposite of t is equivalent to what? Cosine of t, right. So that means cosine of t is what function, odd or even? Even. What about sine of the opposite of t? What does that equal?
Opposite of sine.
The opposite of sine of t. Right, so that was odd or even? Odd. What about tangent of the opposite t?
Opposite of tangent of t.
Opposite of tangent of t. So tangent is odd. So what's the reciprocal identity for secant? We're going to use that to figure out if secant of negative t is odd or even. Of just t?
Yes.
What's our input in this case?
Negative t.
Right, so it'll be the opposite of t. But let's look back up here. What is cosine of the opposite of t equal to?
Cosine of t.
Cosine of t. So we can just replace that with substitution and say it's 1 over cosine of t. But what does this look like? What trig function? What's the reciprocal of cosine?
Secant.
Secant of t. Right, so it's just secant of t. So, if we input the opposite of t and we get the original output, what type of function is secant of t? Even. Right. And cosine of t is even as well. So there's a relationship right there. So what's the reciprocal identity for cosecant of the opposite of t?
1 over sine of opposite of t.
Of what?
Negative t.
Yep, the opposite of t. So what does the sine of opposite t equal?
1 over sine of t.
Yeah, man, negative sine, the opposite of sine of t. Right. So what does that look like? What trig function?
Opposite of cosine of t.
Yeah, opposite of cosecant of the opposite of t. So that means cosecant is what? Odd, even, or neither? Odd. And what other function that it's related to is odd? Sine of t is also odd, right? So what's cotangent of opposite t? What's its ratio identity?
Cosine of opposite t over sine of opposite t.
So what is cosine of the opposite t equal?
Cosine of t.
Okay, so that's our numerator. What about our denominator? What is sine of the opposite t equal?
Opposite sine of t.
Yep, the opposite of sine of t. So what does that look like in a trig function? First off, is it positive or negative trig function? You're going to the opposite. Yeah, because there's only one negative, so it's the opposite of something. What trig function? Okay. So in my test, we gave you, tangent of t, that's odd. Can you prove it to us? How would you prove it? Yeah, you could do sine over t, yeah. You could do exactly what we did down here with our ratio identities. You could do that for tangent of t, tangent of the opposite of t. Because we know that cosine of t is what? Odd, even, or neither? Even. And we know sine is odd. So if we know that there's an odd and an even, we can figure that out and help figure out if tangent of t is odd or even. So, hint, hint, it's probably the other test. Tangent is always odd. So everywhere there's a reciprocal, so cosine was even and secant was even. Sine was even and cosecant of t was odd. They're both odd. And if tangent of t is odd, then cotangent of t is odd. What questions do you have before we move on? Okay. So the trig functions also have what's called a period, and so they repeat themselves. So how far around the unit circle do we have to go before we repeat all the cosine outputs? What was it?
2 pi.
2 pi. Why 2 pi? Why?
That's how long it takes to go fully around the circle.
Right. So cosine of t, its period is 2 pi plus t. And the t is because if we start at pi over 3, I'm going to start here. I'm going to have to go all the way around the circle. That's 2 pi.
No, the period is 2 pi.
Okay.
All the way around the circle is right back where you started with, not
Okay.
plus t. Period is 2 pi.
Okay. So the book, don't ignore the t part on the book.
The book you're wrong.
Okay.
Concept.
Okay.
The period is 2 pi, no plus t.
Okay.
They're doing something else with
Okay.
that plus t.
Then I will ignore the t part.
They're trying to show the cosine of t is equal. If you wrote cosine of t equals cosine of t plus 2 pi, that's true. The
Right.
period is 2 pi.
Okay.
But if you wrote the equation, go ahead and write down up there.
Okay.
Cosine of t is equal to cosine of t 2 pi plus t. So that's what the book's saying. Is it's just saying every 2 pi makes it back the same, but the period is 2 pi.
Okay.
Okay, thanks.
All right. So then, what do you think the period of sine of t is?
2 pi.
2 pi. What do you think the period of tangent of t is?
Pi.
Why is it only pi though? It was 2 pi for everything else. It's 2 pi over 2. Yeah, you can divide by 2 and you can leave pi. But if we look at the sine of tangent, tangent is what in quadrant 1? Positive or negative? Positive. And what's tangent sine in quadrant 2? Negative, right. Because it's your sine over your cosine. And cosine is negative. So if I have a positive divided by a negative, what is that sign? Negative. So that's why tangent is negative in quadrant 2. So what's tangent sine in quadrant 3? Positive. In quadrant 4? Negative. So if I go around, I have positive, negative, positive, negative. Is that a pattern? Can you already tell that it's a pattern? So we don't have to go around the whole 2 pi to find a pattern. We can just go half the circle and pi.
And the values are
And the
the same.
values are the same way, because they go the same pattern. So if we look at tangent, this is 1 over root 3, it's rationalized, 1 root 3, and then it's going to be negative root 3, negative 1 over root 3. And that'll repeat on the other half. So, tangent's period is only pi. What do you think secant of t's period is? Not 1 over 2 pi. It's a really good guess, though. But periods aren't reciprocals. So, if we go back to here, if this is the value of cosine, our x-coordinate, and it takes us 2 pi to repeat it, the secant is just the reciprocal, but it will still take us 2 pi to repeat it. Because we still have this one value here, and then we have x. So, secant of t's period is
2 pi.
2 pi. What's cosecant of t's period? 2 pi. Because it's related to sine's period, which is 2 pi. So what's cotangent of t's period? Pi. Because it's the reciprocal of tangent of t, and it's related to x. So what equation graphs the unit circle? What's the general equation for a circle?
X squared plus y squared equals r squared.
Equals what?
R squared.
R squared. But what's the radius for the unit circle?
1.
1. So it's just x squared plus y squared equals 1, because 1 squared is 1. Right. So if we use this on here, if I draw a triangle, what's this distance right here? Just in general terms of x, y, and 1.
1.
What's this?
X.
X. Because the radius is what? 1. So then this distance is, this leg is
Y.
y. Right. So it's just the Pythagorean theorem. X squared plus y squared equals to 1 squared. But what do we know is related to x on the unit circle? What trig function? A little louder? The cosine of t. Right. So cosine of t. We're going to just put some substitution in like we did earlier. What's related to y? A little louder?
Sine.
Sine of t, right. Sine of t. And I'm going to square that equals 1. And then just for notation purposes, we're going to declutter this and take away some parentheses. And I'm just going to write it cosine squared of t plus sine squared of t equals 1. This little 2 up here, I know, does not mean that the cost part is squared. It just means the whole quantity is squared. And you have your evaluations on your tables. So if you guys can remember to turn in your homework and fill out your evaluation sheet for next Tuesday, that would be great. Plus there's a quiz on Tuesday. And coming to our office hours. So there's your homework assignment and our office hours. Josh has one on Fridays, 1 to 2, along with his regular lab hours. 2 to 3. Okay. Apparently 2 to 3.
You have your other homework to turn in.
Oh, and my name is... For your evaluation, my name is Daphne Evans. And if you did not get your homework back earlier in class, you just turned yours in, didn't you? That's what.
You need your evaluation letter by Dr. Scott.
Okay. I think that has to be another pass. Now I know where we're you guys have to
Oh, they didn't send it to me, so
You know,
I'll...
because we've been...
The vice president, is there anybody who lives to officers? She was writing them all down.
You know what I mean?
Well, I should, but it's not coming to me right now.
Okay, yeah, I can look it up. I mean, I know a lot of the titles are okay.
Is it Crystal? Or,
It might be Madeline.
Madeline?
Yeah.
I feel like